Good question, good question. I did want to just show, for the people doing the enter the matrix domain, what they can expect. So here's kind of what you're going for in terms of your matrix function. So that's what you should get at the end of your matrix domain. Sorry? And at the end of image processing, for instance, you'll be able to make Obama icons of yourself, and you'll be able to do a blur animation of blurring an image. And at the end of the mathematics domain, you should be able to make a Mandelbrot set animation. At the end of biology and physics, you should be able to do graphing calculators and animate graphs like cannon fire and things like that. At the end of biology, you should be able to make multicolored games of life on toruses and Mobius bands and things like that. So, yes?
Like multiple.
Yes?
Is this range here supposed to be 254 instead of 54?
Potentially.
I think it's
Play with that. Play with the quad AV.
Is it the right way to get the characters? Like that?
Well, that's one way.
One way, okay.
Yeah, there are many different ways. So play around with it and see if there's different ways.
Does it mean to create a pattern for the background?
So creating a pattern would be just to play around with populating that grid with a background image. Maybe instead of a blank image to start with, you want to start with periods or dots or circles.
Where's the DFNS workspace?
So if you are accessing defunds, built-in defunds library helper things, you're going to write copy defunds whatever your function name is. And that'll pull in the defund. What? Yeah. That's sort of out of the scope of what I think we should go over, but you can use the IDE to explore that.
Oh, so I didn't know if there was just like a user doc of what's available.
Yeah, so if you want to see what's available in the defunds, so if you go to defunds.dialog.com, you can see that. Okay. I encourage you to try to not use, don't use the library mentality. So if you can, don't use pre-written functions for this. Try to explore the code as its own rather than using the existing stuff.
Well, and you have like this get UTF-8.
Yeah, so UTF-8 get is one of those where I'm okaying it.
You don't have to write your own UTF-8.
Yes, you will not have to do that. Quad UCS is also your built-in UTF-8 decoder, et cetera. So there's some hard barriers which we're going to accept as library calls. Those have to do with UTF-8, XML, and JSON, and PNG images and JPEG images, things like that. So codefunds has a built-in image loader. So if you're in the image domain, you're just going to load the image in. I'm not going to make you parse JPEG. So, yeah.
Is it wrong to assign the character sequence to a constant, a variable?
Let's see.
Like if I want to assign this to the right like that.
Yeah.
Is that fine, or
Yeah.
does it violate the?
Well, just play with it. Just see it and think about, does it violate the principles or not? See if you think it does or not, and we can talk about it as your solution comes out.
I don't want to be sparked with my
Well, so do with it, see of it, and look at it, and then what we're going to do is we can demo some of these out. We can play with some of these, and you can see some of our solutions, what we decided to do, and we can code golf them, find ways of making them better, stuff like that. So figure out how to do it, but be aware of the principles, because you're not going to just follow these principles as rules, because they're not rules, they're principles. So, yeah, so just think about it. Does it follow the spirit? Using variable names inside of your session is common because you're at the top level and you're trying to play with data. So sometimes you can't remember that data. So you just want to store that data to work with. So that is fine, right? If you need to name your data so that you can work with it, that's okay, right? The point is to understand where you should be using names and where you shouldn't be using names. So names for abstraction, potentially iffy. Names for referencing real instances of things that you're using in the thing, potentially okay. In my compiler, for instance, I generally, all my names appear at the top level, and I have a name per pass, and then a set of helper functions in the passes potentially are given small names. I'll show my compiler a little bit so you can see my interpretation of these principles in a particular use case. under the proviso that that's one use case.
I mean, we're probably some distance apart.
Yes. So I'm perhaps a pure extremist when it comes to certain things.
People who write APL code for money often use them.
Yes.
How do you do error handling in APL?
Do I show that or do I not show that? Do I want to show that or do I not? La 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 la. All right, I'll show a little bit. Okay, so basically you can manually signal errors with the signal system function, and you can signal things like a domain, a rank error using the number codes, and you can look at the documentation and find those. And then those can be trapped using quad trap if you're in a traditional traditional programming environment. I don't recommend you go with that. Instead, what you can do is you can trap error codes inside of defunds where this is what will be run here. However, I think in version, is 16 gone with dynamic trapping, or is it still lexical trapping? Have we fixed that?
Well, it's going to be dynamic. Well, yeah, I mean, I think the correct answer is dynamic.
Okay, so I think in 15 still there is what I consider one of the most serious bugs in defunds to have been allowed to survive across multiple versions of APL. And that would be that error trapping was lexically scoped rather than dynamic. And the whole point of error trapping is dynamic scope. Yeah. So, however, I think that has been fixed and won't be a problem. So what it means is that sometimes you won't capture errors that you expect to capture. And in those cases, you actually have to sort of create a new evaluation frame so that it pops into the appropriate place to get to your trapping. But that's just an ugly thing. This is what you should get out of it. Is this allows you to trap this error or multiple potential errors. So you can do the set of errors that you want to trap here, or things like that. Right. And then whatever you do, it does here and then returns out. Yeah.
I mean, you could show the main error is 11.
Yeah.
11 division by 0.
I didn't actually want to try to do anything because I was afraid of what would happen, but okay, fair enough. Yeah.
WS not found. Is there any import something?
In what?
I'm just trying to copy that symbol.
Oh, not system, defunds. So copy defunds,
Oh, okay.
UTF-8 get. Yeah. Yeah, yeah. Yeah, defunds is the name of the workspace from which you're copying things. Yeah. Is anybody doing image processing? Okay. How's it going? Oh, sorry, I'm just like. Okay.
I don't understand why displaying a box in V displays 3 different lines since.
Oh, because there are new lines in there.
Ah.
Yeah. Yeah. So there are line endings and things like that.
It takes an argument. Just print it out.
I'm just doing math. It's
Cool.
easier to draw.
Cool, cool.
What's the argument with GFX in it?
The name of the namespace that you've compiled, getting ready. So all right. So you're working on that now, aren't you? All right. Let me show you how to get up. So, for those of you who are working where you might be working with the graphics system, what you want to do is you want to be inside of your codefunds checkout, and you want to have loaded codefunds up, and then you'll have this codefunds workspace. Now, the codefunds workspace.
I think you need to show loading the workspace as well. That was here everywhere.
Something like this. Assuming that you're in the right path, it'll load based on your current path. And once you have that, you're going to need to configure it for your system. So there are a set of variables. There's the compiler you're going to use. So there are these 3 variables that you want to set. And AF prefix, if you guys just follow default install, should be user local on all platforms except for Windows, but we don't care about that on Windows. This is going to be probably AF CPU for most of you, unless you're brave. And then this is going to be the name of your compiler. So VSC on Windows, GCC on Linux, and Clang on Mac. Once you're there, you're going to, you need to create a sort of a codefunds object to work with so that you can access functionality. So I just do test codefunds fix, and I just create a namespace with the identity function. And when you run that, it should compile it, run it, and create the right testing object for you. And then you can refer to codefunds functionality from that. And so your gfx init, you can then initialize your graphics functionality with that. And then I can do things like loading in an image. I think. So I have this. What is that? Oh no, Paint 3D, that's not what I wanted. Okay, so then I should be able to say load image. Okay, yeah, all right, so I will use, I'll load it as color, which is the default. So say image gets codefunds load image tick, like that. And if all goes well, you'll have your image, and it will be loaded in as an RGB or something like this. And then you can display that image by whoops. Okay, there we go. And then you get your display, and you can start accessing graphics, playing with that, and so on, and so forth. Okay. You might have to hit escape or close multiple times. I'm still working on that funny little image loop, things like that. And I noticed that it might take 1 or 2 tries to initialize the system. Again, that appears to be some weird display stuff, so there might be a little roughness around the edges to work with, but yeah. And this is also how we did the life animation, is we used animate instead of display, and animate works a lot like the power operator. And Imager is one of these plotters that will allow you to display certain things. You've also got plotter, histogrammer, and I think those are the 2 other ones that we have. You probably shouldn't play with those until you've played around with a little more APLs so that you're used to how things work. Because they require you to provide input in the right format and things like that. But yeah, that's towards the end of your problem domains. That's what you'll play with to visualize your things. Okay. How's it going over here? Okay, great. And when you run it, it comes up? Yeah, cool. All right, excellent. Yeah.
So,
and we'll probably want to take a break in maybe, say, 15, 20 minutes, grab some coffee, 5-minute break, come back, stretch your legs, that kind of thing.
trying to get random numbers.
Yes, random numbers.
Problem is
Yeah.
getting different random numbers.
All right, so remember your order of evaluation. Your random function is going to take whatever it's on the right and give you random stuff based on that. So if you want 7 random numbers, you have to give it 7 things on the right-hand side. So ask yourself, how many things are you giving it on the right-hand side? Which one is that? Yeah, sorry. So what does functional programming mean to me? So coming from the scheme background, I am not what I would call in the type theorist, pure functional programming domain. I currently don't have a use for monads, for instance, in the Haskell style or these kinds of things. Instead, functional programming to me means data flow. It means a way of thinking about the flow of the program without the use of unnecessary state change that is difficult to identify, or with a focus on functional composition and a focus on operating on values instead of references. So thinking of the world as values rather than thinking of it as references. Thinking of it as flow of state through a set of transforms as opposed to mutation. Yeah. Recursion, to me, so traditionally I would have said recursion is an important part of functional programming. I have now reached the point where I feel recursion is a useful but generally not necessary aspect of functional programming. So one of those things, it's like the if statement. I now feel that the if statement does not warrant the amount of attention that it's given. And I think that that should continue to be the case going forward based on how our architectures and systems are changing. So to me, functional programming, you have the scheme, you have the Haskell. Now I feel that it should be moving more towards a data flow as a concept, as opposed to some of the other things. And you'll see that when I show my compiler and my philosophies around it. It'll be directly obvious how I view that. And to me, my compiler very clearly expresses what I feel is my epitome of functional programming. But yeah, lots of data flow.
Also, do you think it's a mistake to separate the language from the editor? I mean...
I think it's a mistake to use an editor as a concept. Yeah. So I think the editor itself has become a problem, but remind me to talk about that a little bit later, because that's he's heard me rant on that, but yes.
Can I get your help?
Cool.
Do you know what this is when I run it?
Yes, so that's because you haven't changed your variables, right? So you need to change compiler, AF prefix, and AF lib to be the appropriate things.
Okay.
So because right now it's trying to run Windows Visual Studio, and you need to change VSC to Clang.
I got it.
And then change AF lib to AF CPU, most likely. And then you can try to run that. Yeah.
Try to load that class.
Yeah, so in that triple, you can assign a triple, or you can just refer to them individually without the parentheses. In each variable, just codefons.compiler gets whatever, yeah.
Try to load that file.
You haven't put it as a string. UTF-8 get accepts a string as your path, and strings are single quotes.
Oh.
Yeah.
Okay. And just out of curiosity, when I want to Google stuff, related to APL,
Well, help.dialog.com.
help.dialog.com.
Yes. Or Mastering Dialog APL. That's a book that covers most everything in it. If you need that, it's a little bit more industry, not as much fun. Yeah, yeah, it's only 800 pages, and it's a lot of frameworks, APIs, that kind of thing for business.com. DYALOG. Yes. Something simple. Yeah, you're in the middle of the debugging stack. You need to do a reset. Yeah, so don't forget about reset. If you get into a space where you're inside of the stack and things are not working the way they should, a reset will pop you back up the rest of the debugger and get you back into the right state. All right. How is the lonely middle road?
I think it's on concatenate.
Catenate is join. It's joining two matrices together or two arrays together.
All right.
And if you read the docs, you'll find that on help.dialog.com. The language reference has the definition for catenate and examples. But what are you trying to catenate right now?
I'm trying to do exactly
Which one?
this,
Oh.
concatenating these random languages.
Okay. So what's your input? You have T, right? Which is a matrix, right? So imagine how you would connect a matrix with a vector. Along which dimensions does it need to be connected? Which side? And play around with comma and first axis catenate. That's bar comma. Play around with those two. Those are the catenate. Bar comma. So it's the comma with a bar. Yeah. Play around with those two with different values and see what you get.
So I'm working on the
Yes.
matching, right?
Cool.
So
Cool.
I have this I have 0, 1, and then 2, 3, 4, 5. Sorry,
What did you do here?
This is counting. I'm trying to count the depth of the deepest nesting.
Wait,
right?
you
Am I
run
doing
that
wrong?
and that's what you get?
Yeah. So this gives.
What the? Whoa.
Quad equal gives you.
I didn't know key did that. Wait, we have a monadic key? Oh, wait, no.
There's monadic key.
No, what?
Yeah, it uses,
When did this happen?
no, that's been there from the start.
That's weird.
It's probably a mistake.
That's creepy.
Even Roger says it's probably a mistake.
So I probably shouldn't use this to solve this. Huh?
Uh,
No,
Okay.
it's fine.
that's
I mean,
interesting.
It uses it generates data, simply the indices.
Right. So
Yeah.
I'm trying. If I can just measure
Yeah.
I'm trying.
You're trying to measure how many.
How many you can go on the top before you get to the next one on the bottom,
Interesting.
Except
Yeah,
I don't know
you
how
could
to-
play around with that. Also, play around with some of the scalar primitives like equality. So play around with equals a little bit too.
Okay. Well,
Yeah.
equals will give me bools, right?
Yeah.
But bools aren't useful for detecting the depth, right? Or
Are they?
are they? Okay, I'll
Play around with it.
All right.
Both, I like the way you're going because that's not a way I would have thought about it. But that's interesting. Yeah. So we're doing with parentheses nesting depth.
I don't. Well, actually, okay.
Yeah,
so
it's interesting. I don't know. Yeah. Play with that. I like that way
There
of
must be
going.
some suggestivity at work.
Yeah.
What you said you used for the AFP.
AFCPU is what I would recommend if you don't have a highly reliable GPU programming environment.
Okay.
Yeah. Yeah, that can cause some problems. Okay, what are we doing over here?
Just trying to download this.
Oh, it's already in the shared folder.
Oh, really?
Yeah. Here. Woo-hoo-hoo-hoo. No. So you missed the USB stick? Yeah. Also, we have a Lambda, the functional array channel on Slack. We'll have a link to the shared folder, which you can download all this stuff from, including the installation guide. However, on the Mac, you're going to have to do some symlinking, most likely.
Okay.
So,
I can help you with that.
yeah, okay. So he's got some people. But you're going to need to make sure you have, is it Homebrew? Is that what it's called? Yeah. Installed, yeah. And your Xcode tools and X11, Xquartz, all that good stuff. Okay.
This one down. It was actually working fine. Now it returns 500s on the request.
So,
Hey, Morton, get a call into Bramley. Try APL is down. We crashed it.
So the site is up, but like if I do IO 10, the evaluation is broken and returns 500s.
I think what's happening is it's trying to restore your session or something. If you were to delete your cookies,
Okay.
so if your session looks broken rather than.
Okay, good.
My PNG is failing to load.
What did you do just before?
I'm not quite sure.
Are you in the local directory that you can find it?
So here I'm in the directory.
Okay, so can you do a sh reset?
No, it's each time you type.
Oh, did you do your graphics in it?
Yeah. Change the compiler to C lang.
Yeah, you ran that, but you didn't. No, not save GFX. You need to do GFX init. So see that line there? Yeah, because that's
Yeah,
what
no,
it can't
the-
find the internal bindings
Okay.
necessary for.
Yeah, no, the save was just so I
Yeah.
didn't have to go
Oh,
through
okay.
that
Yeah,
step
cool.
again.
Yeah. Init, that one right there.
Yeah.
Yeah.
And then test is
Yeah.
just an arbitrary message file.
You didn't call it test. What did you call it when you fixed it? Oh, you did call it test. And it compiled. Oh, are you on Mac?
Yes.
Did you do all the symlinks?
Yeah. I got that example to run here. That was the Hello World thing.
All right, go back. Let's go run something in there. Back to the dialogue.
Okay.
Did you do the latest checkout of CodeFunds today?
Yep.
Problem is it can't find your file, so something is not. Do a reset and then go ahead and run util dot test the string identity, all lowercase. So single quote identity. Yeah. Yeah, see, your compiler is not able to load the right stuff, so it's not finding it. So let's go to this. Let's go into your build directory. It's building them, but it's not finding them. That's not good. So if we go back to the analog. Yeah. Okay, so that's the problem basically. Is it's not able to load in that object file. So if you go, thank you. So if you go into your terminal into the codefunds repo and build, go into the build directory, and then do an otool-L on one of those dilibs, specifically the test clang one. Let's see what happens. Oh, you don't have
Oh, AF CUDA?
you don't, yeah, you have to do AF CPU because it won't be able to load the CUDA libraries.
Okay.
Yeah.
So, hang on, we'll go back to this.
Yeah. Yeah, so that'll solve your problems most likely if you use AF CPU.
Okay.
Yeah, because the Macs don't have the CUDA stuff on them.
Is there good graphics drawing routines included with this to play around with stuff, or is that
So there's
ambitious?
that's what the imager plotter and stuff. So what you can do is you can, if you do, are you doing image processing?
Basically, I have a crazy idea of.
Sure.
Do you know what dual contouring algorithm is? It's a way to find ISO surfaces.
Oh, okay. Yeah,
It maps really nicely onto array processing, so I figured that might.
Yeah, so if you implement that in here, then what you can do is you can produce images as arrays.
What about 3D?
Yeah, so you can do 3D plots.
Okay.
3D plots, if you want, I can quickly implement a 3D surface plot for you.
We'll see. I'll
Okay,
start with
if
the
you
2D
get
case,
to the point where you think it's ready for 3D, it'll be a few lines in a commit, and I'll have a 3D surface plot up for you.
Well, I'll start with the 2D case just to
Okay,
simplify it.
cool. Yeah, I can add that in later today if you need it. Yeah, the graphics stuff is a new feature in this release of codefunds, so it's kind of yeah. All right. Let's see how we're doing. Working? Or are you just listening?
Just
Okay, that's cool. Yeah.
So in SSCP,
Yes.
the author modified power mod to Fibonacci mod to click Fibonacci.
Yeah.
Is that an example of suggestivity?
Yes, a little bit. Yeah. And in fact, you could try to play with implementing power mod here if you wanted to, and see what you get.
But there are no recursion or if statement. How?
Yes, there are. But see if you can do it without it. See if you can implement power mod without using if statements and recursion. If you need to, all right, I'm going to show you guys a little bit of how you use recursion and if statements in APL so that you can start playing around with more complex stuff. And really by that I mean using your old techniques so that I can go tell you that you're wrong and to do it the right way. But let's just do a quick implementation of factorial. Where are we? Here we are. Okay, so in factorial we ask if the input is less than or equal to 0, then return 1, else take the argument, multiply it by the recursion of 1 less. And that should explain how recursion and branching works. So if you guys want to do stuff that uses recursion or branching, you can do it that way. Yes?
question. Is APL's goal is executing the GPUs, good GPU, basically.
No, that is my goal. So APL has a strong history of executing on vector processing machines. It was one of the only language implementations available on some of the very large-scale vector machines in the 80s. Partly because nobody knew how to get other languages onto the vector machine, so APL mapped very well to those. APL itself right now primarily drives Wall Street, big oil, finance, insurance, medical, bio, and some other domains, startups, databases, that kind of thing. That's where it currently is used heavily in production.
That's where I came across it in databases.
Yeah.
This is an obscure thing. It's
It's been winning the fight on databases. Basically, in the domains where APL is used, they get really upset when people say, oh, look at all this SQL stuff I've got, because they scoff at it because SQL has been too slow for them for years. And APL significantly outperforms any of the popular databases that people are familiar with.
right here. Is there open source database?
There is, on Dialog, there's VecDB, and maybe, and later today, Morten will probably give us a demo of some database type stuff, working with tree.
I can see this being usable in time series databases and stuff like that.
That's exactly where it sees a very significant portion of its use. Now, my goal is twofold. Really, it's to scale up what people using APL can do, because the problems are getting to the size and the hardware is getting to the point where to handle large-scale data, you want really good parallel execution. So so I'm sort of scaling in two dimensions. I'm scaling on the performance side, where I want to get APL to really work efficiently on the GPU, on modern vector machines, because that's been a neglected problem for the past 20 years. And then the other one is to make it possible for people to scale their learning of programming, computing, and to these machines from the beginning all the way up. So I want to make sure that we have a language like this that we can teach to high schoolers, for instance. And actually, most of these, not to put you guys on the spot, but most of these problem domains were problems that high schoolers went through with almost no guidance. Well, a lot of my guidance, but they wrote the code themselves in a 2-week, 12-hour session with no computing background at all. They did these domains. So you as computer scientists have it a lot harder, because you have to unlearn a bunch of things before you can learn it. But that's what a lot of these problem domains were oriented towards. Anybody who's seen the live stream will be familiar with this, but let's just look at some code that I've been working on. And this is how I view APL. I should preface it that, as Morten says, this is not the kind of code that most people would be writing, but it is a highly optimized form of coding expression that I find extremely useful in my own work. So I can explain why in detail, and I tried to on the Hacker News discussion explain it, but I can explain in detail why I find this to be a particularly useful way of writing code. However, it is not what I would call the average Joe code that you'll find in most APL communities. So yes, and then I think we should see Morten's code to see perhaps a decompression. So yeah, and Morten will show something more akin to, I think, what the normal APL programmer thinks about code. So if you guys will have noticed in your checkout, this is the Codefons compiler. So what we have is a set of files, A through U, .cd. That's the compiler proper. You have tests, some other stuff, but that's where the compiler rests. I believe the total line count is maybe around 1,500 lines or something like that, including the runtime. I didn't bring my t-shirt with me today, but I have a previous version of the compiler that fits on the t-shirt. The start here should immediately throw up lots of red flags for most people in their best practices. Why am I using single letters that apparently have no significant meaning? And the reason is that this is an homage or a form of self-documentation that points to what you're about to see. So it's my "there be dragons" here note, because famous array programmer Arthur Whitney was kind of infamous for doing this thing in his code. And because I'm using a style of C code in the runtime that very closely mimics some of Arthur's conventions, I put this here to let any APL programmer who sees this sort of know ahead of time, hey, you might want to prepare yourself for this class of programming rather than other stuff. So the way the compiler is designed is to fit onto 2 pages at a time on the system.
Quick question.
Yes?
What does it compile?
All right, so it is a compiler written in APL defunds, compiling APL code defunds, which is a slight extension, but right now it's basically defunds, the language you guys are learning, to C++ linking into ArrayFire for the CPU, OpenCL, and CUDA. And it is designed to execute, the compiler itself to execute in parallel on the GPU. So rather than...
Fire itself executes on GPU.
So it's not quite self-hosting yet, but that would be the eventual goal. So executing of the compiler itself on the GPU. So rather than a compiler that runs on the CPU that generates GPU code, we've now got a compiler that executes on the GPU itself. So this is the starting point, and this is where we begin with the overall style. So on the left, you have the regular... This is A and B. And this is the public interface here. And this is the back-end and front-end linkages. So you've got your back-end C compiler stuff going through. And then you have, below that, if I stop getting email, you have your AST description. And this allows you to sort of understand the overall structure of how it works as far as our data types. So we're still working with arrays. However, we're going to be using a linearized representation of ASTs, known as the quad XML derived format. And this is how I sort of document what I'm working with. So inside of my compiler, there will be these types of nodes and those fields. So we have a set of 11 fields, DT, KNR, SGV, YE, which is the depth, type, kind, name, reference, scope, guard level, values, types, inferred, environments, and live variables at that point. And every node will have those fields throughout the compiler. Early on in the compiler, there won't be as many fields. Later on in the compiler, you will have all of these fields. And then every node will have a type, which is either A to Z, something in A through Z. And then, remember that we're talking about macro level views, right? So rather than doing traditional work, I have a set of accessors for nodes and a set of accessors for fields. And this is where the naming conventions start to come in. So I care a lot about names and making sure that names are not used to do things that structure should be used to do, and they can instead be leveraged to communicate within the domain of compiler writing. So for me, that means I'm trying to write so that my variable names stay within the domain of compiler writer concepts. And that would mean that we have these nodes where ZM, YM, any of these are going to be taking an AST as the right argument and returning a Boolean mask over that AST, identifying all of the nodes of that type. The AS and so on accessors are going to use that mask to extract out the set of nodes of that type inside of the AST. The field getters, when given an AST, are going to get out that particular field for every node in the AST. So you can think of these sort of like column accessors and row accessors, or record identifiers and field getters inside of a database or something like this. And so that's sort of where we're framing this whole situation. So we've defined our exit, we've defined in our minds, our incoming point of view, which is going to be these things. And everywhere, these names are valid, right? This is a flat namespace, so I only use those single letter names almost always in this form when they're in the right mental scope. So then, what's the first thing you do when you have to go in and compile something? Well, you have to parse it. So here's the parser. And notice again, 2 pages, all the code on one screen. This is important to me. So I work to make sure that all of my code fits on the screen at the same time for any given space of the compiler. And I work to make sure that I don't have to scroll. And so you'll see why I don't feel that editors are a good idea. Structured editing is actually interesting because structure editing is another form of eliminating scrolling. If you have folding text editors, that kind of thing. The folds are ways of getting rid of scrolling, or that kind of thing. This is just an extreme way of doing that. And you'll notice there is zero syntax highlighting. So this style of programming is, in a way, a very aesthetical as well as aesthetic style of programming, because what I'm doing intentionally is stripping out as many of the tooling assists and aids that I get from other environments that make my life easier, so that I am only allowed to simplify my life by simplifying my code. That's the goal, is to use my tools in the inverse manner, make it more difficult to leverage tooling so that I can only really leverage language level simplifications and architectural level simplifications. Because once you reach a point where your code is complex enough, then you can't just play little fiddly tricks inside of a piece to make your code simpler. You have to start making broad sweeping architectural changes in order to simplify the code. And so everything here is pushing me to have to do that, because I don't have all of the tooling support that you might use to get away with slightly more complex code. So I'm doing everything I can to only allow me to be able to think about the code in this one way, so I have to make it as simple as possible. And so this is a peg grammar. So the implementation for peg parsing is up there in the underscores. You guys can see and use that if you want. So that's a peg parser combinator library for peg grammars. And on the left-hand side, you can see, did you have a, oh, okay. On the left-hand side, you can see the terminals of the parser. And then on the right-hand side are the non-terminals for parsing the system, and they just use the combinators over here. Interestingly enough, APL is a slightly ambiguous syntax, and so we have to do type inference while we're parsing. So this compiler will identify which variable references are data types and which variable references are function types, and infers that through here. It also supports recursion, forward references, and all of that other stuff. Because it needs to do type inference, it also has to be aware of all of that other pieces. So it has to be able to do forward referencing and things like that. Now, here's the compiler. So the compiler fits on 2 pages of text, 12-point font. Yes? But it's not actually scrolling. TT is the bottom end of it. It is pushing the limit a little bit over here. So I'm working on simplifying that. I actually really need to code golf this. This is the inline pass. So this code right here inlines functions, and it's a little bit long. Way, 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 way too long, actually. That's probably double the size of any of the other compiler passes. MR could probably also be simplified. Yeah, so it's way too long. So we'll work on simplifying that. But yeah, so the point is, when you think about your compiler, I find it much easier to write compilers if I can see the entire compiler all at once. Because now I'm able to reason about every aspect of the compiler and see it at one go. So you were asking about code duplication. One of the reasons code duplication isn't a problem is because I can see all of my code.
Well, I'm more just, if I have to fix a bug in one piece and I forget that it's duplicated it somewhere else, that's my biggest concern. I don't fix that.
Yeah, well, but you can see all the instances of your duplication at one go.
So you wouldn't put another instance in another file?
Probably not.
Okay.
If I had to start crossing so many different file boundaries, I might put a function there to separate that out. But oftentimes, I'm in separate spaces, so there is no code sharing there, because they're very separate, very different pieces. So there are a few things where they are common, and in those cases, I might have these helpers. So these are a set of helpers where I need to do things, and these might be used elsewhere. Now, there's another subtlety to this code which you guys might not have seen, and that is that none of these is a line of normal expression code. Every single line on here is a function definition, because this is written in the trains point free style. So these variable names that you're seeing here, like this one up here, D is not a reference to a piece of data. D is the function, the field getter, accessor. And so this whole line is the generation of a single function by function composition. And so the whole compiler is just one giant long data flow graph and implemented without branching, recursion, looping, any of that stuff. It's just function composition put together like this. So if you want to see a little bit more about how the syntax works, you can, well, let's do that. Let's take.
Was that style chosen for the ease of implementation on a